have an incredible egg, geode, sugar crystals. Excellent. Okay. And Ms. Summers, who's presenting first?
Adina and Toby are present first, and then Shima and Sarah after that.
Okay.
Sugar crystal. Our shopping list is water, multiple fruit colorings, skewers, silver extract oil, granulated sugar, mason jars, spoons, and cups. Our hypothesis is that if we change the amount of sugar left over in the solidify, then the food coloring will not change the texture amount of time it takes. Our variables are food coloring or without food coloring, and the food flavor or without. We also changed recipes when the first one we were using did not work. Our first attempt at making sugar crystals did not succeed. We used iron powder, which might have been the cause of the sugar crystals to not solidify or turn into crystals. One jar was very hard, but might have just been solidified iron powder and sugar, and the second jar did not solidify and was wet. After the iron powder didn't work, I did not use the iron powder anymore. Second attempt. The second try at making sugar crystals did not work either. But we found out the real cause of our problem. We were not adding enough sugar, which did not allow the sugar crystals to form. If we added more sugar, then hopefully they would solidify. After a while, in the second result, we noticed one sugar crystal had formed. Third attempt. For our third try, we used a pot that seemed to work much better than using the microwave. And when we came to school the next day, we found that the sugar crystals were completely solid. They were in the jar, and even after we poured hot water on them to help speed up the process of getting them out, they still would not come out. Fourth attempt. We made non-kosher ones with the blue raspberry flavoring and purple food dye. This worked well, and we got a stick with crystals on them. After we poured out the liquid, there were crystals awaiting us at the bottom of the jar, so it was a success. In conclusion, we made almost the same amount of successful sugar crystals as that. This is a proof your only resources were microwave in a pot, therefore it was able to create crystals that were successful. Also, the ones that we made that were successful were this is 2 cups of boiling water and 3 cups of sugar. And then we're going to add food flavoring and food coloring. And then we're going to let that sit for about 20 minutes. But normally we would put this in a jar, and after 4 or 5 days, we're going to open it. We're done.
Oh, you mean it doesn't happen in like 4 seconds? Okay, no problem. Excellent, girls. Thank you. Okay, good job. Okay. Okay, we ready?
What is elephant toothpaste? Elephant toothpaste is a foamy substance caused by the rapid decomposition of the hydrogen peroxide using yeast and warm water as a catalyst, which is a substance that increases the rate of a chemical reaction. How rapidly the reaction proceeds will depend on the percentage of hydrogen peroxide. Hypothesis. Our hypothesis is that if we have a higher percentage of hydrogen peroxide, chemical reaction will explode more. Question: will let elephant toothpaste erupt more with a higher percentage of hydrogen peroxide? Variables. The variables we used in our experiment were the different percentages of hydrogen peroxide. We used these 3 different variables: 3% hydrogen peroxide, 6% hydrogen peroxide, and 12%. Materials for elephant toothpaste. A clean 16-ounce plastic soda bottle or water bottle, 3%, 6%, and 12% hydrogen peroxide liquid, 3 or more tablespoons of warm water, liquid dishwashing soap, food coloring, small cup, funnel, and yeast. The method to make elephant toothpaste. First, we used a funnel to pour half a cup of hydrogen peroxide liquid into the bottle. Then we added 3 to 5 drops of blue food coloring into the bottle. We then added about 1 tablespoon of liquid dish soap into the bottle and twisted the bottle around lightly to mix it. In a separate small cup, we combined the warm water and yeast together and mixed for about 30 seconds. Last, we used the funnel to pour the yeast sweating mixture into the bottle and watch the chemical reaction begin. Results. First, we tested 3% hydrogen peroxide and saw that it went very slow into the jar.
Very nice.
Second, we tested with 6% hydrogen peroxide and saw that it went faster than 3% and erupted more.
It also looks stickier, that one.
Last, we tested with the 12% of hydrogen peroxide and saw that it went very fast and erupted beyond the usual amounts of our other two experiments.
Not this time.
This time it did.
Yeah.
Our conclusion. First, we tested with the 3% hydrogen peroxide, saw that it went very slow and didn't erupt much. Second, we tested with 6% hydrogen peroxide and saw that it went faster than 3% and erupted more. Last, we tested with the 12% of hydrogen peroxide and saw that it went very fast and erupted beyond the usual amount of our other two experiments. From this, we concluded that the higher percentages of hydrogen peroxide, then the elephant toothpaste will erupt more and the chemical reaction will complete.
Okay. Awesome. Nice work, guys. Okay.
Today, we'll be talking about magnetic slime. We had two questions. One, how far can the magnet be from the slime and still attract the slime? And two, does a half cup of slime move faster towards the magnet than 1 cup of slime? Our hypothesis for the distance of slime. I thought that the magnet would be able to be at least 2 inches away from the slime and the slime would still be attracted. Atom thought that the magnet would be able to be around 4.5 inches away from the slime and the slime would still be attracted. Our hypothesis for the amount of slime. I thought that the small amount of slime would go a little faster towards the magnet, but not a lot. And Atom thought that the bigger amount of slime would go faster towards the magnet.
Materials. Gold, blue, liquid starch, iron oxide powder, color coloring, and neodymium magnet. Regular magnet, which doesn't work. Materials 2. Borax, water, fabric paint, aluminium glue, iron oxide powder, and neodymium magnets. Materials 3. Liquid starch, aluminium glue, iron oxide powder, and neodymium magnet.
All variables. We will change the distance of the slime from the magnet and see if it's still attracted to the magnet. And we will see if a half cup of slime moves towards the magnet faster than 1 cup of slime.
Result for distance from the slime. For first recipe, the slime had to be touching the magnet.
Steps. Stir 2 tablespoons of iron oxide powder into 1/4 cup of liquid slime. Continue stirring until mixture is smooth. Add 1/4 cup of glue. Mix with your hands. Always powder with disposable gloves so the iron oxide powder can stay. You can play with it like regular slime and attract it to magnets, and you can blow bubbles in it. Steps 2. In one bowl, mix together 1 cup of water and a half teaspoon of borax powder. In another bowl, mix a half cup of water with 5 ounces of algae glue. Pour the borax mixture into the glue mixture and mix well. Take the slime, flatten it out, and put iron oxide powder in until magnetic. Steps 3. Pour 1/4 cup of school glue into a bowl. You may need to use a spoon to get all the glue out of the measuring cup. Add 2 tablespoons of iron oxide powder and stir well. Pour in 1/8 cup of liquid starch. Stir the mixture very well. Knead the slime with your hands and magnetic slime.
Result for distance from the slime. For first recipe, the slime had to be touching the magnet, but no more. For second recipe, the magnet could be 1/8 inch away from the slime. For third recipe, the slime could be 1/2 inches away from the magnet. Result for amount of slime speed. We were not able to test this because the different recipes had to be different distances from the magnet, so it would be a fair comparison.
Conclusion. We made magnetic slime. We mixed together glue, iron oxide powder, and liquid starch. We used a neodymium magnet because it was the only type of magnet that would attract the iron oxide powder. We were trying to find out how far the magnet could be from the slime and still attract the magnet, as well as how fast it could move towards the magnet We found out that the magnet couldn't be any farther than 1 inch away from the slime and still be attracted to the magnet. We ended up not being able to test the speed. And right over here, we have some of our effects. This one was from our first recipe. This one was from our second, and this one was from our third.
Okay,
They're magnetic slime.
excellent. Good job, guys. Okay, now we have our last group from the 5th grade. I want to hear more about this egg geode. Go ahead, guys.
We made samples a few weeks ago, and since then it has fallen apart. Here's what it originally looked like.
The Incredible Egg Geode by Zach Greenbaum, Zuggle Diana, and Mamsi Wendy. Question: does changing the amount of alum paramount we put into the water affect how many crystals the egg has? Variable. How variable is the amount of alum paramount we put in the water?
Hypothesis, Zach. I think the most powder we put into the water will affect the crystals because the crystals are made of alum powder. No, I think the most alum powder does change the amount of crystals. I think the most alum powder might change the crystals.
How it works. The heated alum solution contains particles of alum powder in it, and as the solution cools, these particles of alum begin falling to the bottom. When the alum particles settle on the bottom, they begin crystallizing. Coating the shell with alum powder beforehand gives the suspended alum particles a surface to which they can more readily attach themselves. The particles that settle onto the interior surface of the shell crystallize quickly, but you will also see evidence of crystallization on other parts of the shell, as well as on the bottom and sides of the bowl.
A fast egg geode. When we put the alum powder on the eggs, we probably put more powder than the other. One egg has a well thickness and the other has barely any.
Our second attempt. In our second attempt, we used black food coloring instead of green. We also left a possible stick in the water by accident, so crystals also grew on that. One of the eggs had no crystals and the other had a lot. The one with no crystals was at the bottom of the jar, so got no crystals. The one with lots of crystals was above that one. They were stacked. We figured out that in the first attempt, instead of putting too much on powder, we left one of them on the bottom of the jar, like we did in this attempt. Conclusion. We were trying to figure out how many crystals we could get to grow on eggshells using an alum powder mixture. We realized that the eggshells resting on the bottom of the jars made it so that the eggshells grew less crystals. We stacked the eggshells so one would be closer to the top of the jar with the mixture in it. We varied the amounts of alum powder and realized that 3/4 of the cup of alum powder grew more crystals than 1/2 a cup and made the crystals more.
Refer to Steve Banger Science, and you can copy those links and.
Okay, good job, guys. Okay, if you guys had to do another follow-up experiment on geodes, what might you do differently?
We would get a bigger bowl so the crystals grew on both eggs.
Okay,
And we would keep the things inside the stuff.
say that again.
We would keep the things that we're making inside the.
We would keep the crystals inside the eggs. They fell out.
Okay,
Because this is this, and those two are those two,
right,
These two are these two.
and
got it. Okay, great. Very nice. Okay, so in the 5th grade, so we saw 4 different projects. Feel free to wave, people. We saw, or hide behind something if you prefer. And we saw some hypotheses that worked out, some that didn't work out, and that's okay, right? That's what we do in our science. We try something else. Excellent. So guys, with the magnetic slime, I'm not sure I asked you guys, what would you do next? What would be another follow-up experiment that you would try?
We would try different recipes, different amounts of ingredients.
Just trying different recipes. Okay, good. and girls with the sugar crystals, did you try different temperatures with making the sugar crystals?
We switched from a microwave to a pot and a burner.
Okay. And how did that change things?
It worked a lot better with the pot.
Why? What's your theory why it worked better?
Because we were able to dissolve the sugar while it was still hot.
Got it. Okay, good. And so if you made it hotter, do you think that would be good to make it go faster?
I don't know.
You don't
kept
think
it
so?
on the hottest.
Okay, great. And back over here with the elephant toothpaste. So what I was noticing was that on the second one, it moved very slow. Do you guys have an explanation why?
Because the water and yeast wasn't totally for each other.
Ah,
Water was probably starting to get a little cold by then, so we should have probably gotten a little warmer.
okay.
But this is our second time. This is our first time, and that was the third one.
Got it. Okay, great. Excellent. Good. Round of applause for the 5th grade and for Ms. Summers. Okay, anything else that anybody wants to add from their project, from their work? Okay. Okay, so it is 1:08 now. We will be going a little bit further down the hallway to go to the 7th and 8th grade rooms. So we'll need a couple of minutes to get set up over there. So please don't go away, and we will be back shortly.